if we take a battery and we connect it to two sides of a light bulb, like the situation here, what's going to happen is the electrons within this light bulb are going to start to move towards the positive terminal, or the higher electric potential. And so they're going to start to move in that general direction. Now, when we represent this in a schematic, we call it, in some kind of vectorial representation, we don't draw the actual light bulb and the battery as how they look in real life. We use a shorthand notation that's fast and simple. Here would be our battery with the positive and the negative. And we always draw the wires in a box shape. And the light bulb is a circle with a squiggle line in it. And so the electrons are going to start to move towards the positive plate. Now, if we were to look at one of these wires here, a little section of wire, perhaps blow this up here, and we look at one of those electrons. The electrons are going to start to move towards that positive terminal, but as they do so, they are not going to move in a straight line. Instead, they're going to move more so like a leaf caught in a current in a stream, and so it might even double back at times. However, the overall trend is that it drifts towards that positive terminal. And so we refer to the movement of the electron as the electric current. So the electrons are flowing just like the river flows, and it's telling us how fast. The value that we write down for the current is telling us how fast the electrons are moving. The higher the current, the faster it is that they are moving. We refer to the drift velocity is the net velocity of that charge carrier, in this case the electron, as it moves in the wire produced by the electric field. So again, the electron doesn't move in a straight line. It drifts just like a leaf might drift in a stream. Or you can think of it this way, like a football player, a running back who is trying to avoid the tackles from the other players. He's going to run around them. But when they talk about the overall forward progress, they might say that the running back has gained 5 yards forward. But the running back, in the meantime, may have run 15 yards. But they say only about his forward progress, how far he is from where he started. And so it's the same thing with the electrons. They don't actually just move in a straight line. They kind of drift towards the positive terminal. The symbol for the electric current is the letter I. Might not make sense here, but when they first talked about electricity, they didn't know about electrons. And so they were not calling it a current. They were just talking about the intensity of the electric signal. And so speculation is that the letter I stands for that word intensity, how intense the electric signal is. When talking about how fast the charge is moving, we're talking about a rate of change. We're talking about, if we go back to this diagram, we're talking about how many coulombs of charge pass this point every second. And so the unit is a coulomb per second, which we abbreviate as an ampere, or an amp for short. And so the equation we see is the total amount of charge that passes divided by the total amount of time that we are looking at. And so the equation is that the current I is equal to the total change in charge from that point, how much charge passes that point, divided by the time. Again, it looks like our speed equation. Distance over time, only in this case is the amount of charge over the time. Now, depending on what book you may read or who you may talk to, the direction of the current may be different. When Ben Franklin first started talking about electric current, he didn't know about electrons and protons. And so he took a guess, and he guessed that it is the positive charge that was moving. And so he said that the charge moved from positive to negative terminal. It turns out that he was wrong. It's the negative charge that is moving. And so the actual motion of the electrons is from the negative to the positive terminal. Some people just like tradition, and they say that the current goes from positive to negative However, some people have made the switch and now say that the current goes from the negative to the positive. So depending on who you talk to or what book you may read, you may see one or the other. In all actuality, it doesn't matter as long as you're consistent with the direction that you choose. And so conventional current is referred to what Ben Franklin had discussed, and then the motion of the particles, or sometimes the current that we talk about now, is the opposite of that. Now there's two different types of current. There's AC, or alternating current, that we see from outlets, and DC, or direct current, that we see from batteries. So DC is direct current, and AC is alternating current. A direct current is going to be that we always have a positive on one side and a negative on the other. And so the electrons always meander towards that positive charge. But in alternating current, AC, we're going to alternate the direction the electrons are moving. At one point, we'll have positive on one side and negative on the other, and so the electrons start to move one way. But then we're going to reverse the positive and negative. And so then the electron moves back. It's kind of like the high and low tide, the water coming in and then going out. So the electron simply goes back and forth. It alternates that direction. This is what's coming out of your outlets. You actually have three wires. The bottom wire is the ground. This is where we define the electric potential to be zero. It's more of a safety feature. You don't have to have a ground. This wire is called the neutral. A lot of times we tie this into ground as well, so this would be 0 volts. And this we refer to as the hot. And this is what's going to fluctuate between positive and negative. So if we look at a graph of the voltage for that outlet, the alternating current, so the voltage versus time, what's going to happen is that's going to fluctuate. It's going to be positive at one point and then negative in the other, and so therefore the direction of the current will also fluctuate as a function of time as well. So the current goes one way and then the other, and we refer to that then as alternating.